Hello guys, in this video the first thing that I want to do is I want to finish most of the chunks, or at least some frame data and object reading. And the second thing that I want to do is I want to talk about Fusion game structure, the PAIM header and everything that's under it. I don't know where to start. Probably the first thing that we are gonna talk about is the file structure. I'm gonna use the code from Anaconda because it's much easier to understand it than the old version of my decompiler, because, well, it's a mess. You can't really understand anything here. So let's see how it works. We have a first file here, which is bimbam.py, and it's pretty simple. It gets the input, it's the first argument this passed to the file with the command line. This is the modified one, not the original one. All it does is creates a folder and puts the compiled file here, and also changes its name to the original name from the editor file name property. So the first thing that it does is it gets the file name, it gets the name of the exe file, so it can use the its name to create a folder here. You see, these folders are not real names of the apps, they are just the names of exe files. Then it checks if the file is a CCN file. A CCN file is basically an exe file, but without the actual exe header. So it's like that one part that starts with PAIM or PAMU header. And if it is a CCN file, it just reads the game data, which starts with this header. You can see it here. The magic header is PAIM or PAMU. You can see it here, it's in the commented code, but yeah, that's pretty simple. And if it's not, if it's something different, then it creates an executable data class, which is a reader for an exe file. I'm gonna get over here, close this one so it won't disturb me. It's probably in data, yeah, it's here. We can see what it does. It does exactly what calculate entry point does in my decompiler, so it's literally the copy of this function. It reads all the stuff and creates a pack data, reads it. Wait, where does it? Oh, yeah, it does it here. Actually, for the old games, the first shared header is not 7777 hex, but 8748. It's for 1.5 Fusion games. And the pack data is just a chunk list filled with external data chunks. External data, right? Yeah, and if it's a normal header, then we are just getting the pack data. And if it's the game header, then PAIM or PAIM, then we are just getting the game data. It means that it's a Multimedia Fusion 1.5 game that has no pack data. It means there is no extensions or transitions here. And once we read it, we also get the game data and read it. And in the write function that we don't need for now, there's an executable class. We are getting it the same way. We call the find append offset. It's in the data PE file. This is the copy of my calculate entry point function. It does the same thing. And reads all the stuff and saves it to a variable, so it can be used later to write the exe header. It won't work if you modify anything in the game data class, because the size of the data, what is it called? I forget. Of the data section will change, and as a result we'll get the broken P header, which will break the executable and it won't work anymore. Yeah, and then we move to game data. This is the main class. If you go back to BimBampy, we see we dump everything from pack data that we found, and also everything from the okay, let's not move too, let's not go too fast. We read the game, then if we have the pack data, we dump everything, and then we dump everything from the game data. So we have files variable here. These are external files that are, as I said before, used in 1.5 games. So if it's a 1.5, or maybe it's actually 2.0 game, also it's Media Fusion 2. Maybe they also use it here. We are also dumping the embedded files, and then we do a translate. It's a function from PAIM to MFA function, PAIM to MFA script that translates all our game data into MFA file format. We call the new game, we pass the new game and also this print func, so it can output stuff. And as a result, we get the MFA file, which then we can simply write, and that's all. So let's move to the game data class. It's a bit different than in our version because, well, it works a bit differently because we read the header, we check if the game is Unicode. We did it before here. I commented that out because we don't have the settings class, and I don't really like the idea of using this class anymore because it just makes the code harder to understand. But we do it here, then we read stuff, and then we are creating a new chunk list and read all the chunks, and then save them to these variables here. I'm not doing this because I don't want to create a new instance of an object, allocate more memory, and do all that stuff. I'm just doing it directly in the game data class. So yeah, we are pretty much doing the same thing as we do here, but with less loops, less memory usage. And the write function is pretty much the same. We are adding chunks, and well, yeah, that's all. In the chunk list, this is the chunk.pyx, pyx. This is the Cython file. See, well, that's a thing that converts your Python code to C++ and then converts it, compiles it into a native model. It's used here because it makes the code much faster if you need to do a lot of loops, maybe a lot of memory allocations, as I said before. We have all chunk IDs here, all chunk names, well, all chunk names that were used in well, old builds of Fusion. We got some stuff for 1.5 games that is not used at all because Anaconda doesn't support old games. And we got this key generation here. This is a create transform function, which is pretty simple. We have it in our decryption class, and that's the thing that I added myself. It checks the build number and creates a new key, and also there is a transform function somewhere here. Oh, it's in the chunk cm.cpp file. I'll show it to you later. And yeah, this is my code that well, this code is only used in builds that are past 284 build number. So it's that thing that gave us the lib error before we made a new decompiler, and then we call the transform and get our decompressed class, decompressed chunk. This is obfuscated because I don't really know why. Basically what it does is it generates the key, it use this key in this transform function. And there's also a function called C, which is probably the weirdest thing here because I don't really know what it does. I'm gonna try to find it somewhere. Okay, C. Let me find it really quick. Actually, maybe it's not C. It's probably not C because I can't find it, but I had the deobfuscated version somewhere, and that's how it looks. So I think there's nothing interesting in this structure. Oh, we also got all the chunk readers and got this file, which contains some weird stuff that is just randomly been placed here. Not sure why it's used. Okay, so let's move to our new decompiler. I actually never spelled it, like never pronounced it. How do I even say it? Okay, let's call it CTFAK because why not? So when we run CTFAK, we can see that it took less than a second. It took like 30 milliseconds to read all the stuff. And we actually decompressed and decrypted all the chunks. Okay, it still takes less than a second. That's nice, but the real problem, there was one big problem in the old version, is images. I fixed most of the image problems in the 0.7 version. It was never actually released, but I still fixed most of the stuff, but the images were still very slow, and I probably know how I can fix it. Let me get some drink so I can so I can talk easily. It's just water. Okay. So the main problem with images was the translation to the format that we need. I'm gonna open the image bank class here, and it's pretty big, and it's not all of it. So the thing that happens here is we are reading the game structure. Let me find the code that is actually used for normal games like 2.5 without any modifications. So this is the main code. We get the handle, we get some more properties, and then we come to the load function, which actually converts the image to the format that can be used to get the bitmap, get the PNG format. The main problem here is these functions. They are giving you the tuple, yeah, I think that's how I pronounce it. And the problem with these things is we are creating a new instance of an object every time we return it. And this thing is called for each image. And if we go here, we see a lot of stuff going on. And my idea was to put all the stuff in a C++ library that is also used for decompression of 1.5 games and the decryption of the new ones. So it probably could be a bit faster, but I'm not sure. I'm gonna do it later, but for now, I want to do some more frame reading. So we got the, I'm actually gonna add the background and flux properties here. So we do public. I'm gonna finish the frame reading by today. This video is gonna be shorter than the last one because it's kinda late already, and yeah. So let's do at least something useful. So we get the background. Why is it green? It's a structure, but why? Okay, I don't really care. So we do background equals chunk reader, read color. Do I have read? Yeah, I do have read color. And we also have flags here. Let me find this thing. Yeah, we got these flags. which are gonna be useful in the future. Can I just add them like this? I do. Now I need to remember how it works, because I forgot how to use bits dictionary class. So I probably set the flag here to chunk reader dot reads, or which one of these I use. I don't remember. Okay, so it's 32 bits, and I'm gonna cast it to. Well, I can simply do this. There's no problem. Okay, what else do we have? Oh, we have this thing, and this is pretty funny thing, because we'll have to do a lot of stuff with it when we actually come to the decompiling. But for now, let's just simply add this class here. Let me find it. Yeah, here it is, object instances class. So I just add it here, and then I do count equals chunk reader read int 32, and then I'm not gonna do anything, because I will need a separate class for this. So I just can do found count then objects, then we can add this character here and run this thing. As a result, we can see there is objects on frames. Well, that's kind of obvious. Right. Also, it uses a lot of memory, and I don't like this. I'm not sure why it does this, but it does, and that's not really good. Maybe I can dispose the reader after reading the file. Let me actually try this. So after I read this thing, I can do chunk reader dispose. It's not actually a good idea, but I can probably dispose not all of them, but most of them. And this way it didn't help at all. Then I don't care. I don't know what else I can do. I actually do know what's wrong, but I have no idea how to fix it. I can probably do reader dispose, and then do chunk reader dispose, and I shouldn't ever do it in the loop, because it will cause a crash. And once I do this thing, it didn't help at all. It made everything even worse. Maybe actually it didn't. Oh, I don't know. Okay, let's forget about the memory for now, because I don't care. We have enough memory for the fusion game to be loaded at this to load everything at the same time. So now we have the object count, and actually I'm gonna add the object instance class, public class object instance. It's gonna be a chunk loader, but it's not really a chunk loader. We're just gonna implement all these functions, and also add the constructor. And once we have this, we can actually read some information about this object. Okay, so here's everything that we need, that we know about the object, basically. A handle is the handle of the object. Object info is the handle of the frame item that we have. Parent type is I have no idea what this is. Layer is that's pretty obvious. It's the layer. Oh, that's the bad example. of this layer, yeah. And there is some weird stuff going on, and I probably only need the second one. Also, it's quite easy to break click team. We just need to add more than 65,000 objects and it will break. Actually, I wonder what would happen. I'll try at some point. And we also got the empty variable here. I'm not sure what it does, but it's there and it probably does something. And because it's here, we can actually, what the if we don't read it, then everything is gonna break, but wait, I need to check this out because that's kind of weird. Okay, give me the object instance. Not this, not this, not this, not this, no. Oh, yeah. Yeah, so we actually skipped 2 bytes here. I'm confused, but okay. I should probably just ignore this. And we need a public list of object instances. We can actually use an array for that, but yeah, I don't want to do it because well, I don't really know why, but I like lists and I like C#, and I don't know what I'm trying to say. Okay, so we do for loop, and we do this to create a new instance of the object instance class. We pass chunk reader here. We read it, and we add it to our list. And now we can do a logger, log object instance. Well, let's do some basic parameters like maybe object info, and I forgot this thing here. And when we run it, we get a lot of stuff here. Yeah, and I think something is not right here. Okay, this looks normal, and I'm satisfied with the result that we got. So yeah, let's just hope it works like it should work. And I want to do some stuff with objects, and I'm gonna add the base class object info. Object info is a chunk loader, which is actually not a chunk loader. I'm just gonna add some basic stuff here again, and gonna open the object info class here. And oh, I already don't like how it looks. Especially I don't like this part because loader is a chunk loader, but the object command class it scares me a lot because it is this long, and we also got a lot of subclasses like text counters and all that stuff. So for now I'm just gonna add the base object info class, and let's see how many properties we got here. We got the handle, we got the name, public int handle, public string name, and I think that's enough for now. Let's just get our basic class reading, basic chunk reading. Oh, I'm gonna steal this little part and I'm gonna put it here. And I'm gonna remove all this code. So we're gonna get the header and we are gonna also get the name. These are two things that we need for now, and here's their IDs. I'm gonna paste them here, and I'm gonna get the name equals. Now we can use var. Oh, I don't know how I'm gonna do it. Oh, I know. So I just do name. Read the. Fuck off. Read the white string. And then the second one is the object header. Here I can do a handle equals. Oh, that's a huge mistake. Chunk reader. What an idiot. Chunk reader. And let's move back to this structure here to see what we need. Object header is the first one and it's 2 bytes long. Read int 16. And now we can move to game data. And I'm gonna change one little thing here. We do game data, get game data, and it's a function that takes no arguments and returns our game data. And we are gonna also change our class. We do this, and then we do game public game data game. And once we did this, we can do game, and there we can return game. And in the program class we can add a static variable public I file reader game parser. We can assign it here. I'm sorry. Oh, the hell. Oh, static. And from now we can. I hope it already does work. I'm not sure, but I'm also gonna add the thing that stops it from breaking. Oh, it's already here, right? Yeah, it's already here. So we can now do we're gonna do some magic. We get the program game parser, get game data. Yeah, I forgot the main part. I want to get the actual list object info. That's how I called it. Right. So we need to find the chunk that contains all our objects, which is frame items. It has this ID. Now we can do case one count equals chunk reader read int. Oh. And we need the break here. And why are you stupid? It should be public too. Right. and we're also gonna assign the default value. And now, what the hell? Now we will do some magic to get the actual name. Game data frame items find. Also maybe select A. Handle object info. Are you stupid? Okay, something is broken. Select object info. Okay. Okay, something is not. It's really broken here. Maybe you should just find. Yeah, probably this one. Yeah, this one. And now if we run the code, yeah, it does work. We get this, and we got all the stuff that we actually have in frames. Also, it's not in the alphabetical order like in the game. It's the I'm not really sure how it's sorted, but it does work, and we are already recording for half an hour. So I think that's enough, because, well, we got the objects. Oh, I just gonna show you one little thing. You can now go to this file and change it to like actually not like this, and it's you saw this. It works perfectly fine. Not perfectly fine, but it works. Now it should work perfectly fine without any errors. And yeah, we got some objects that have no name, but I'm not really sure actually why this did happen. It's on that weird frame, but we got most of the data. We got only the name actually. We'll get most of the data in the next video, but yeah, we got the new key here because it's the new game that uses new build of Fusion, and yeah, it worked. And okay, that's enough for today. I'm gonna continue working on it tomorrow because I'm kinda tired and I have school tomorrow, so when I have free time I'll probably finish the object reading, the object properties reader, and then I'll work on a new info file writer so we can actually get the source code of the game. But for now, that's all I have, so goodbye.